Friends, hello friends, welcome to my channel. We are going to discuss about intersecting chords in a circle. The intersecting chords theorem, also known as the chord theorem. This theorem states that relationship between the four line segments formed by two intersecting chords within a circle or outside the circle. So we have an important theorem, and first of all we are going to prove that theorem, and again we solve some problems based on the chord intersecting theorem. Again, so look at here, what is the theorem? If two chords intersect in a circle internally or externally, then the products of the measures of the line of the segments of the chords are equal. So we have given a circle and two chords AB and CD. These chords are intersecting at point O internally. The segments of chord AB are AO and OB, and the segments of chord CD are CO and OD. Therefore, by theorem, we show that AO into OB equals to CO into OD. So, to show that, to show this, first of all, we join AC and BD. Thus, we have a pair of triangles. Thus, we have pair of triangles, triangle AOC, triangle AOC, and triangle BOD. In triangle AOC and triangle BOD, the angles with vertices of same colors, the angles with the vertices of same color are of same measure. That is, angle C and angle B is equal, and angle A and angle D is also equal, and angle AOC and angle DOB is also equal. Why? Because angle C and B and angle A and D are corresponding in the same segments of a circle, and angle AOC and angle DOB are pair of vertically opposite angles. So we are going to apply these conditions to prove that we show that these triangles are similar, and we apply again the property of similarity. So angle ACO equals to angle DBO. Why? Because these angles are in same segments. Again we show that, again we have found that angle OAC equals to angle ODB. Why? The reason behind this is also the same, because they are in the same segment. They are in the same circular segment, so they are equal. This is the theorem of circles. So angles are in same segments. Again we have third pair of angle is angle AOC equals to angle DOB. Why? These are the pair of vertically opposite angle. Pair of vertically opposite angles. again we saw that therefore by criteria a angle by a criterion, similarity criterion, for the similarity triangle AOC is similar to triangle DOB. So again we know that in similar triangle corresponding opposite sides of the triangles are in proportion. So therefore the corresponding side of AO is DO. Therefore AO upon OD equals to corresponding side of OC is OB. OC upon OB. Again we are going to use cross multiplication. What is the cross multiplication formula? The cross multiplication is AO into OB equals to OC into OD, and this was the theorem. So we have proved that these segments AO into OB equals to OC into OD. Again in case 2, these chords are intersecting each other externally. So these chords AB and CD intersect externally at point O. So we again saw that the same result is also valid here. AO into OB equals to OC into OD. So what is the method to show that? To prove this, join AC and BD. Again we know that in ABCD, ABDC is a cyclic quadrilateral. And we know that cyclic quadrilateral, the sum of opposite angles is 180 degree. So the sum of opposite angles is of 180 degree. Therefore angle A plus angle CDB equals to 180 degree, and also angle CDB plus angle ODB is also 180 degree. Why? Because they are pair of linear pairs. These angles forms linear pair. CDB and ODB forms linear pair. Therefore CDB and CDB goes to cancel, and angle A equals to angle ODB. Similarly angle C equals to angle OBD, and what angle AOC equals to angle BOD. Why? This is the common. So again we are going to, we know that by AA criterion, by AA angle criterion, by AA criterion of similarity these triangles, triangle AOC, triangle AOC and triangle BOD are triangle AOC and triangle BOD triangle DOB are similar. Why we have write DOB not BOD? Because angle A is corresponding to angle D. So A must be A. If we write A first, then we have to write A D first. If we have write C, then we have to write B, because this angle C is same as the angle B at OBD. So therefore we cannot write anywhere, we have to write it as corresponding minors. So again we are using the same property of proportionality, that we know that also in similar triangle opposite sides of triangles are in proportion. So AO upon OD equals to OC upon OB. So this implies that AO into OB equals to OC into OD. Thus we have proved our theorem, and we have seen that if the chords are intersecting each other internally or externally, they are going to be divided in such a way that their segments, their product of the segments are equal. Again we are going to explain that how can we solve these problems based on this theorem. So we have given a problem that the two chords PTR QTS are chords of a circle, and PT, we have given the length of PT ST RT, and we have to find out the length of QT. That is, we have to find out the value of X. So we use the chord intersecting theorem. The segments of chord QS are QT and TS, and segments of PT and segments of PR are PT and TR. So therefore we have explained earlier that the relationships between these segments would be by the chord intersecting theorem. QT QT into TS equals to PT into TR. PT into TR. And what is QT? QT is X and TS is 10 centimeter, and PT is 3 centimeter, and TR is given as 15 centimeter. So X equals to, by linear equation, we have linear equation in X, we have X equals to 3 into 15 upon 10, and this becomes 45 upon 10 centimeter, and this is X equals to 4.5 centimeter. Thus we have find the length of QT equals to X. We have used here chord intersecting theorem. Again we have second problem, that this is same as we have given AP equals to 4 centimeter, BP equals to 3 centimeter, PD equals to 14 centimeter, and PC equals to X centimeter. So by chord intersecting theorem, the segments of chord BD are BP and PD, and the segments of chord AC are AP and PC. Therefore by chord intersecting theorem, AP into PC equals to BP into PD. And what is the length of AP? AP is given as 4 centimeter, and PC is given equals to X, and BP equals to 3 centimeter, and PD equals to 14 centimeter. So x equals to, by we have a linear equation in x, so therefore this multiplication becomes division here. This becomes 42 upon 4 centimeter, and this equals to x equals to 21 upon 2, that is equals to 10.5 centimeter. So another we have another example. What is the another example? This is the example of external bisection, external intersection of chords. So the chords are intersecting each other at point x. The segment of S are Sx and Rx, Sx and Rx from the x. So we apply Sx into Rx equals to Px into Qx. Px into Qx. And what is the Sx? Sx is x plus 10. Sx equals to, since Sr equals to Sx equals to Sr plus Rx, and Sr equals to Ax and Rx equals to 10. So Sx equals to x plus 10 and Rx equals to 10. So therefore Px equals to, and Px is what? Px equals to 11 plus 9 into Qx equals to 9 centimeter. So again this becomes x plus 10 into 9 equals to into 10 equals to 20 into 9. Again solving this, x plus 10 equals to 20 into 9 upon 10, and this goes to cancel, and this becomes x plus 10 equals to 9 into 2, which is equals to 18, and this x plus 10 equals to 18, and x equals to 18 minus 10 equals to 8 centimeter. So x equals to 8 centimeter is our answer. So thus we have used that, we have shown earlier that the intersection is either internal or external. We can apply the chord intersection theorem, and what we have given, what we have to solve here, DE equals to BE is given equals to x centimeter, and we have given AE and EC. So again DE into EB equals to AE into EC by the chord intersection theorem, and this is x and this is also x. So and this is equals to 4 into 9, x square equals to 36, and x equals to a square root 36, and this becomes 6 centimeter. So the length of DE equals to EB equal to DE equal to EB equal to x equal to 6 centimeter. Again we are moving the next question. And what is the next question? Is the next question we have given that we have given next question, P, Q, R and S are points on a circle. Center O, we have given center O. QS is the diameter of the circle. QS is the diameter, and what is the radius? OS equals to 5 centimeter, and QS is diameter. So OS equals to OQ is also QO equals to 5 centimeter, since OS and OQ are radius of the circle. So and TQ equals to 3 centimeter. So therefore TQ equals to 3 centimeter, and TQ plus TO, TQ plus TO equals to OQ, and OQ equals to 5 centimeter. So TQ equals to 3 centimeter plus TO equals to, so TO equals to 5 minus 3 equals to 2 centimeter. So this distance is 2 centimeter. And again we have the four segments of the given two chords. The first segments of ST, the chord SQ has the two segments ST, and ST into TQ equals to ST into TQ equals to RT equals to TP, and this is the chord intersection theorem. So again apply this. So ST equals to SO plus OT, ST equals to SO plus OT, and this becomes 5 plus 2 equals to 7 centimeter. Again we put here This is the 7 centimeter, this is 7, and TQ equals to 3, TQ is 3, RT is 6 centimeter, and we have to find out the PT or TP. So this PT equals to, this is linear equation, 7 into 3 equals to 7 into 3 upon 6, and this is 2, 7 upon 2 centimeter, and this becomes 3.5 centimeter, and this is the